So just like with the other notes, we have two sets here. We have the notes that are more like factual. Are you guys ready? You ready? We have notes that are a little bit more factual, and then we have the second page of notes. These are the notes that are a little bit more mathy, where we're going to do actual samples of it. So first we have the properties of parallelograms. I'm going to write down what the property is, and then I'm going to draw it in the picture. So we're going to call this parallelogram ABCD, and it's really important that you guys understand parallelogram ABCD. It's really important that you guys understand how things are labeled in geometry. So we do not say A, B, C, D. We do not. We do not go from left to right. Never. Never, ever. If you go from left to right, you will draw your diagram wrong, and you will get probably every answer wrong. Okay? We do not go from left to right. We start with one letter. It does not matter where you start. You can start anywhere you want to. And then we go clockwise. You go around in a circle. Okay? So A, B, C, D. I will test you on that. And the students who get that wrong are the ones who go left to right. Okay? It makes a difference for the bottom two letters. If you go left to right, they will be backwards. Okay, so we start in one, and then we go around in a circle. A, B, C, D. Okay? All right, so what we know about parallelograms is that the opposite sides are parallel, and they are equal in length. Equal in length means congruent. They're parallel and they are equal in length. That means that they are congruent. So the symbol that you're going to see in a picture that means parallel, you're going to see these little lines. That means that those two sides are parallel. To show that different sides are parallel, you're going to see two of those lines. So side AD is parallel to side BC. AD is parallel to BC. AB is parallel to CD. And then to show that they're congruent, we do like a little notch or like a little line. So this side is congruent to this side is congruent to this side. So we're going to say AD is congruent to BC, and AB is congruent to CD. Because equal and congruent are two different things. Congruent is saying like they're not just equal in length, but they're also kind of like in the same position, if that makes sense. Yeah. All right, opposite angles are congruent. Opposite angles are congruent, so this angle and this angle are the same measurement. And then this angle and this angle are the same measurement. So that means that angle A is congruent to angle C, angle B is congruent to angle D. All right, consecutive. Consecutive means in a row. So consecutive angles are supplementary. Anyone remember what supplementary means? They add to 180. So for example, the measure of angle A plus the measure of angle B equals 180. the measure of angle B plus the measure of angle C equals 180. So you can see these two, they add to 180. These two, they add to 180. These two add to 180. These two add to 180. So the angles that are next to each other, the consecutive angles, the ones that are next to each other, they add to 180. All right, last, diagonals bisect each other. What does the word bisect mean? Cut in half. So here's a diagonal. And here's another diagonal. Okay, and I'm going to say that this 1, 2, 3 and this 1, 2, 3, those are the same length. So this half and this half are the same length. And then 1, 2, 3, 4, 1, 2, 3, 4, these two are the same length. So diagonals bisect each other. They cut each other in half. Okay, so we're going to use some of those properties to do some problems. All right, so grab the other sheet, put it in front of you. For this first example, we are going to use that consecutive angles are supplementary. So you can see in this picture we have consecutive angles. Consecutive angles are supplementary. Consecutive angles are supplementary. So that means that these two angles that are next to each other, they're going to add up to 180 degrees. So I'm going to say 10x minus 12 plus 72 degrees equals 180 degrees. And then what should I do? I can subtract the 72, but maybe what should I do with the 12 first? Combine like terms. So 10x plus 60 equals 180. Subtract the 60. 10x equals 120. Divide by 10, and we're going to get that x equals 12. And they didn't ask us to plug in the 12, they just asked us to solve for x. So we're done. Okay? What property does the next one use? They're congruent, right? Opposite sides are congruent. Opposite sides are congruent. Okay, so if opposite sides are congruent, then we're going to say that 5x plus 5 equals 20. Okay, and what should I do? After that, because all the like terms are already put together, minus the 5 so that we can solve for x. Okay, so we're going to minus 5. We get 5x equals 15. Divide by 5 to give us that x equals 3. Okay, and it said solve for x in the instructions, so we're good. What property does this one use? Opposite angles are congruent. Okay, so we have 17x plus 8 equals, I can't read that very well, 19x, it's supposed to be a minus, 19x minus 2. So what should we do? Okay, minus the 17x. And then add the 2. And we get x equals 5. Now, x equals 5 is not the final answer because they didn't just say solve for x. They said find angle F. So what do we have to do from here? Plug in 5. Okay, which one do you guys want to plug it into? Okay, so 17 times 5 plus 8. Okay, 17 times 5 plus 8 is 93. Okay, and so then what do we do? Okay, and how did we know that we were doing that? Yeah, because they're supplementary. So first we did opposite angles are congruent, then we did consecutive angles are supplementary. So we actually used two properties on this. Consecutive angles are supplementary. So 180 minus 93 is 87. Okay. So 87 is what the other angles are. So the measure of angle F is 87 degrees. Okay. Okay, from X to G is 12. From E to G is 13x minus 2. So I'm going to say this whole thing is 13x minus 2. Does anyone know what X to E would be? 12? How did you know that? How do we know that they're the same? No. Diagonals bisect each other. Diagonals bisect each other. Perfect. Okay. Diagonals bisect each other, so if this part of the diagonal is 12, then this part of the diagonal has to be 12. And so now how would we solve the problem? (13x minus 2) equals 24. And then add the 2. Divide by 13. X equals 2. Okay. Okay, example 5 is an interesting one because it actually refers to something that you learned in Math 2 if you guys ever got to this point in Math 2. Do you guys remember problems like this, two parallel lines and a transversal? and you would learn like these two angles are called corresponding angles. Do you guys remember that? And you learned that these are called alternate exterior angles. You guys remember that? Okay. And you remember that these are called alternate interior angles. Remember that? So when we learned about these different angles, we learned that these are corresponding angles and they are congruent. We learned alternate exterior angles. Those are congruent. We learned alternate interior angles. Those are congruent. We learned two parallel lines and a transversal. We learned if we had same side interior angles, we learned that those were not congruent. We learned that those were supplementary. Does that all sound familiar? Like you learned that before? Okay. Now this example, what we have drawn here is we have a parallelogram, and the parallelogram only has one diagonal drawn in. They could draw two diagonals, but they only drew one. And what's actually happening here is you have two parallel lines and a transversal. You just aren't seeing the whole picture. It's like they erased some of it. Okay, so what I'm going to do is I'm going to draw back what it was that they erased so that we can see what other information we could have actually found in this picture, because they want us to find this angle. Okay, so I'm going to put back the rest of the parallel lines that they erased. So here's a parallel line, right? This line right here, and here's another piece of a parallel line. So there's our two parallel lines, okay? And then right here, this right here is our transversal. Do you guys see how it looks really similar to what I was drawing over here? Two parallel lines and a transversal, okay? Now what they did is they said this angle right here is a 96-degree angle. What is this angle over here? 96 degrees. How do you know? They're alternate interior angles, okay? Alternate interior angles. Now, we're not going all the way back to Math 2 because we're not going to do all of these. We are only going to do this one. We are only going to do alternate interior angles. That's the only one that shows up with parallelograms, but it shows up all the time. Okay, so we're going to watch out for alternate interior angles. They always show up the same way. They show up on either side of a diagonal because the diagonal is the transversal. Okay, so the two outsides of the parallelogram are the two parallel lines. Two parallel lines. That's the two sides of the parallelogram. And then your diagonal line is your transversal. So we're just going to watch out for that. Anytime they have a diagonal drawn in a parallelogram and they've got one angle like that, they're probably saying alternate interior angles and they're expecting you to find the other one. It's one that is kind of like a hidden fact that a lot of students miss. Does that make sense? Just a little thrown in there for Math 2. All right. This next one, also thrown in there from a previous math course, is asking you to find the distance or the length of the sides of a parallelogram using points on a graph. Anyone remember how to do that from back in the day? We have a special formula. Anyone remember the formula? It's the distance formula. So we know that opposite sides are congruent. We already know that, right? So we know that opposite sides should be equal in length. We also know that opposite sides should be parallel. So I can already tell that these opposite sides are parallel because like this one has a slope of 0, this one has a slope of 0. This one goes up 1, 2, 3, 4, 5, 6, 7, and over 2. This one goes up 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, and it went over 2. So since they have the same slope on the opposite sides, I can tell that they're parallelograms. But now I want to see what the lengths are of the opposite sides as well. So the top and the bottom are easy. I can just see how far apart these are because they're on straight lines. So if this one's -7 and that one's +6, how far apart are they? 13, right? -7 to +6, that's 13 apart. -9 to +4, how far apart are those? 13. Okay, and that makes sense, right? Because the opposite sides should be the same distance apart. Now, the ones that are a little bit more complicated are these diagonal lines, because those distances, you can't just count the boxes. You have to actually use a formula. And this is where I think we go back to middle school, maybe, to where we learned the distance formula. And this might trigger some middle school trauma, I'm not sure. X2 minus X1 squared plus, anybody? Y2 minus Y1, are we remembering this? Is that, anybody have, like, immediately you had bad feelings in your hearts from that? So if we want to know how the distance from A to D, we're going to have a big square root. And it doesn't matter which one you subtract from which one as long as you are consistent. So for the first one, I'm going to do A subtract D, and then I'm going to make sure I do that with the y coordinate as well. So I'm going to do -7 subtract -9, and then I'm going to do 5 subtract -2. And I can just type that all in a square root all at once. -7 subtract -9. Plus 5 subtract -2. Anyone want to tell me what they're getting? Anybody? What are we getting? I think that's similar to the actual number, but did you put a square root over it? I think it should be 53, though. Should be, because this is 4, that's 7. 2 squared, 7 squared, so 4, 49, 53, square root of 53, bigger than 7? 7 point something? 7.28, okay. So we got that distance is 7.280. Okay, let's do the other one. So we're going to do from B to C. I'm going to do it the same way. So I'm going to do this x minus this x. So I'll do 6 minus 4 squared plus the y minus the y. No, because of the plus sign. And do we get the same thing? Yeah? Yes? Yes? Are we getting it? Same thing? Same thing? Same thing. Okay. So each of these sides is 7.28. 7.28. Okay. We're going to hang on to our notes because we actually are going to finish the other notes. And then for tonight, I'm going to have you guys try some parallelogram problems. So the assignment looks like this. So let's talk about these. Can you guys picture like what we're going to do to solve some of these? Like number 1, what are we going to do? We got some problems with y's. We got some problems with x's. What are we going to do? Yeah, we're going to say the opposite angles. I'm good. No, thank you. We're going to set up, so the opposite angles, because these are the ones that have the same variable, right? We're going to say, okay, the opposite angles are congruent. Okay, the opposite angles are congruent, so we can find x and y. What about with this one? What are we going to do here? Opposite sides are congruent, so we can find x and y. Opposite sides are congruent. What about here? The consecutive angles are supplementary, okay? And then we have opposite sides again. What are they using here? Diagonal lines bisect each other, okay? And then these two are just like what we just did at the end of the notes. They're going to have you draw the parallelogram first, and then you're going to make sure that those opposite sides are actually the same length. Okay. Do we feel like this worksheet is something we can handle? This is comfortable? Okay. I think I'm going to say for tonight, do the front side of the worksheet. Sound like a reasonable amount of homework? Front side of the worksheet? Yeah. All right.